This is a video to help prepare you for a placement test in college algebra. In other words, these are the concepts, at least some of them, that you should know if you completed that course, and as a prereq for any other courses. So the first thing you need to do is be prepared to graph a linear function. And on a lot of these, we might use the graphing calculator. Certainly for this one, we don't really need a graphing calculator. If you have a grid, you want to note that this number is the intercept, the y-intercept, and this number is the slope. Okay, so we can go over here to -6 and place a dot, and our slope tells us that we're going to go up 1 and over 5. Up 1 and over 5, and that would give us a line. Now, if you're doing it on a multiple choice question where the grids are shown on your test, then you'll just be able to graph that on your paper or your calculator and then pick the correct one. Now, this question has to do with transformations. Let me get this up here. So you may be given a function and asked to graph it given that it's moving, all right? And so if you have one of those, and it doesn't have to be anything you actually even recognize, you might be given a picture of the graph and say, okay, what is this one going to look like? In other words, if we had this and said, okay, here's f of x, how is this thing going to look if this is our original? So what you need to realize, and you're going to have to be picking something, when you add or subtract something at the end or beginning of an equation, of a function, that's going to move it up or down. So we'll pick this vertex point. So we know that the vertex is going where? Down 4. So this thing is going down 4. When it's something inside the absolute value or inside parentheses or inside the radical, that's going to move left or right. And it's not intuitive. In other words, -5, I used to tend to think, oh, that'd be going left. But inside, it does the opposite. So this is going to go right 5. All right? So if we took that vertex that is right here and we moved it down 4 and right 5, we know our V is going to look something like that. In your test, you may have something that you don't even know exactly what the function is, but they might tell you, okay, now move it this way, and it would have something in parentheses, something added or subtracted. Remember, this piece that's added or subtracted down here goes up and down. Negative goes down and up goes positive. This piece goes left or right. So in other words, you'll pick a vertex or a main point and you're going to move it these directions, and then you should be able to find your graph. Okay? This one is graphing a polynomial function, and if you have to do something like this or match something, you can put this, you need to note that these are the X-intercepts. And that means here's a factor, here's a factor, here's a factor. And if we solve all those little factors, if we solve them all, like we set it equal to 0, we get x is 0. This one we get set it equal to 0 and we get x is 1. And this one we would get x is 2. So if you put a dot on x is 2, 1, and 0, then we could go to the calculator, and I'm actually going to pull that up just so you can see. And if we put this in just like it's listed, 3x parentheses x minus 1 open again, x minus 2. All right, and then we hit a zoom 6, which is a typical window. And so you can see that I could tell this is going up through 0, turning, and doing that. So you'd be able to either know that this is where the x-intercepts are, but then you would know the shape of the graph if you had to pick it. Okay. All right, a rational function. Rational function looks usually like this, like a fraction, like a ratio. It has some particular things going on. This is what you would do with the calculator, but let's look at this. Here on the bottom of a fraction, what do we know that the bottom of a fraction cannot be? It cannot be equal to 0. So if I take that bottom and I set it equal to 0, then x equals -5 is the one place that that cannot exist. So I know that there is a asymptote, a boundary at x equals -5. That's a vertical asymptote. Okay? The horizontal asymptote has to do with the top compared to the bottom. So we look at the leading coefficients of the top and the bottom. So the leading coefficient here is 1, it's understood. And over here it's also 1. So it's 1 over 1, which equals 1. So y equals 1 is the horizontal asymptote. And so if I drew a horizontal line, whoops, I just erased, sorry, horizontal line right here, those are my boundaries. So I know that's what it's going to look like. And that would help if you were graphing it by hand. If you're picking a graph, you could certainly go to y1 and be sure that you put the top in parentheses and the bottom in parentheses. And then when we hit graph, we're going to see that we did get something like this. And you could use your calculator to do that on the test. But that's what's happening. Now, if you had to graph an exponential function, just understand that when you go in, you want to say 2 raised 2, so you hit your caret key, the x plus 4. If you have an older, like a TI-83, then you have to be sure and do something else, and I'll show you in a minute. But you get something like that, and you could match it. If an older calculator, you would have y1 equals 2, and it would show the caret key. You would have to put this x plus 4 in parentheses. So this is for the older TI-83. The newer ones, actually, when you hit the caret key, give you an exponent box. Okay, I skipped this one. This is graphing a piecewise function. And the thing is, when you're given this, we are not going to have, you're probably not going to have, these parentheses here. So let me take those off for a minute because I want to show you what it would look like in your test. If I can get those and then get my x back here. So you just might have to do that, and you would have to choose a graph. You can do these on your calculator. You could do them by hand, but I wanted to go over how to do it with the calculator because that might come in handy. So what we need to think about for the calculator is that we do have separate pieces all in one function, and when we put it in the calculator, we are going to put the parameters in parentheses and the function itself in parentheses. All right, so we would go to y1 and we would put in x plus 5 and then open, we don't put the if, x greater than 0, and y2, we would put in -3 if x is less than or equal to 0. Now, you find those inequality symbols under second math. All right. The other thing that would be helpful would be if you put it in dot mode, and you can do that per equation, and we'll show you how to do that. I'll show you how to do that on the calculator. So let's pull the calculator up, and we'll go to y equals, and we'll clear that guy out. So we're going to have parentheses x plus 5, and then we'll open another one, x. Now we need greater than, so second math, they're right here, and greater than is number 3, and we put 0. I gotta move this up a little bit, 0, close. We'll go down to y2, and we're gonna have parentheses -3. Be sure you use the baby negative if it's the beginning of a function or a number like that. You don't want to use the subtraction sign. And then we'll open x, we need less than or equal to. So we'll go here, and we have a number 6, and we'll put 0 and close. Now, I said that we would do dot mode, so we need to go over to the far left where we have the kind of line. And once this is flashing here, doesn't seem to be, there we go. So we're going to hit enter 6 times. 1, 2, 3, 4, 5, 6. And we should get 3 dots. And we go back up to the next one and do the same thing. 1, 2, 3, 4, 5, 6. And we get dot mode. Then we're going to hit graph. Alright, so we do get this picture. I actually grabbed that from a screenshot. But what we don't get is the open and closed circles, and those would be on your test question. So you have to be sure and know what that would be. So let's look. This says for everything greater than 0. That's over here. Everything greater than 0, just greater than, not equal to. So that guy has an open circle. This one says for x is less than or equal to 0. That's everything going this way. That would have a closed circle. So for one thing, you would have to pick the right graph that had the right open or closed circles. Then you might be asked about the domain and range. That's always an important concept for functions. So the domain of this thing, we're saying, where does this exist on the x? Well, because we have a closed circle here, it exists everywhere. And if you have to do it in interval notation, which usually we do, sometimes we use inequality, but most times, I think in this test, you'll use interval, why am I writing that again? Interval notation. And so that means you're going to say, for if it's everything, it's from -infinity to +infinity, and that would be your domain. For the range, though, this thing goes on forever up, and there's a value for y all along here, but we don't go below there, so we're not going to have that. We would start at -3, and then where do we go to? +infinity. Now it does have a y value for every number, but it does stop at -3. Their y value is not going to be less than -3. And we have the bracket because of the closed circle there. So if you had to do that, be sure that you know how to do that. All right, let's see. I think I had skipped that one. So we did that polynomial, we did the rational, and we did the exponential. There's another piecewise if you wanted to practice with that one. I think part of this got marked off. So that's probably right there. So is that the same? I think that's the same one. So that's just a repeat, and you can ignore that. I thought I'd given you an extra one. All right, a polynomial inequality. And for this one, I like to use the calculator for this. And so I would go to the calculator, and let's see. I would clear and clear. And so we want to go to x squared minus 6x minus 7. We're going to put that left side in y1, and we're going to put 0 in y2. And then we're going to graph. We get a picture similar to what I've drawn over here, and then we need to find those two x-intercepts. You could find that by factoring, but we can also do this. Second calc 5 and enter 3 times. You get a -1. Second calc and intersect. And we need to move before we hit enter. And we're going to move around till we get to the other side. And enter, enter, enter. And we get the 7. So we know that x is -1, x is 7. Now it's asking, where is this whole expression less than or equal to 0? Well, less than tells you you are below the x-axis, because that's where y is less than 0. So that's below the x-axis. If it had been greater than, you would have been above. All right? So I'm highlighting the part that's below the x-axis. Because we have the equals under there, we know we have closed circles and we have brackets. So that tells me the closed circles tell me I have brackets. Okay? So if it's interval notation, you have a bracket and say this thing exists from -1, follow it, and ends at 7 in brackets. If it were inequality notation, it would be -1 less than or equal to x less than or equal to 7. All right? Let's go here. Let's do this. So this next question, you might be asked to find an equation having a given slope and a point. And you need to know this equation. You need to know this formula. This is the point-slope form. Y minus y1 equals m times x minus x1. And so here's your x1, here's your y1. So we would get y minus 3 equals -7 times x minus 4. And then we would clean that up a little bit, because you usually want it to be in slope-intercept form. And so we would distribute here. We would add this 3 to the other side. And we would have our equation. Now, be careful when you are looking at the test. It may say write the equation and just give you a box, but it sometimes says y equals and it has a box. So if you put in the y equals there, it's going to count it wrong. Be sure you look at the directions. Be sure you pay attention to that. In this particular case, if it had the box, then this is all we're putting in there. All right? You might be asked to, you're given an equation, you're given a line on a graph, and you are asked to write the equation. So what you want to note is that they have given you a y-intercept, and you can find the slope because it crosses right here again, and that's perfect. We go down 5 and over 5, and that tells me the slope is down 5 over 5, which is a -1. So I can write it in, because this is y equals mx plus b form. So y equals -x plus b. All right. All right, so you may have an application problem, And what I would suggest to you is to read it and really read it closely for understanding. A grasshopper's perched on a reed that is 7 inches above the ground. So imagine that. It hops off the reed and lands on the ground about 11.7 inches away. During its hop, its height is given by the equation. So it's saying he's on this little reed and he hops over here. And he's saying that the equation that they give you simulates or models this hop that he makes, and that at different x is the distance in inches from the base. So here's the base. So x is this way and h is this parabola. All right? And so it says how far was, and it should make sense, I would say, that at so many inches you're at this height, at so many inches you're at this height, somewhere you're at the highest point, and eventually you're back on the ground. It says, how far was the grasshopper from the base of the reed when it was 3.25 inches above the ground? So that means we want to substitute 3.25 here for h, and we're solving for x. We can do that in the calculator pretty easily. So if we go here to y1 and put 3.25, and then we go here and put negative 0.2x squared plus 1.75x plus 7. And we hit graph. So there's our horizontal line at 3.25, and here is our curve. Now what we want to think about, because I have that written here, there's two places where that hits that line. We can't see this one over here. I'm going to change the window and make my X max a little bit bigger. I'm going to make that 15. So let's see that. Okay, so we can see both. Do we need this X value here? That's a negative X. That's negative inches. So we don't need to worry about that guy. We're only concerned here. So we'll do second calc 5. And we are over this way, so we'll come back this way a little bit. And we'll hit enter, enter, enter. And we get 10.53. And it will tell you to round to the 10th or the 100th, so watch that rounding. This one says to the 10th. And if you put the right numbers but you rounded it to the 100th instead of the 10th, you'd be wrong. So here, I need to have that be 10.5. That would be my answer. All right? So that should get that one. You should be able to identify even and odd functions. It's relatively easy if you're given the equation. If the exponents are all odd, then the function is odd. If you have one of each, even and odd, it's neither. And if you had all even, it would be even. Even is symmetrical about the y-axis. Odd is symmetrical about the origin. So this one would be odd. Have to be careful. If it's an even and an odd, your answer would be neither. Next, you want to be able to solve an equation that's going to have a radical in the answer, and you have to be able to simplify that radical. So here would be a possible equation you would get. And number one, you want everything on the left and 0 on the right. So I had to subtract 11 here. And I want that to look like that equals 0. All right. Then you have to remember the quadratic formula. And that is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Your a and b and c are the coefficients. So right here we have a 1, an 8, and a 5. So a, b, c. Then it's just a matter of plugging in. Sure, you can do that. Now when you get down to negative 8 plus or minus the square root of 44 over 2, you want to look at this and think to yourself, is there a perfect square factor of 44? Well, over to the side, I've shown that. There is square root of 4 times square root of 11. The square root of 4 is 2, so that's 2 square roots of 11. So now I have negative 8 plus or minus 2 square roots of 11 over 2, and I can divide 2 into all three pieces. That's the only reason you get to reduce that way. So you have negative 4 plus or minus the square root of 11. In your answers in the test, they would be listed separately. That would be negative 4 plus the square root of 11, comma, negative 4 minus the square root of 11. So that might be the way that it would be listed there. Now this one is doing the same thing, except you end up with a negative value under the radical. So we have to know that we're going to have an imaginary number there. So negative square root of, square root of negative 144, that's equal to 12. But since it's negative, we're going to have 12i. So 14 plus or minus 12i over 2. 2 again goes into everything. And so we have 7 plus or minus 6i. And again, that would be listed as 7 plus 6i, comma 7 minus 6i. So if you have a negative in the radical, remember that's going to give you an I. These next questions have to do a little bit more with rational functions. You would be probably asked to find the domain of a rational function. And remember, the domain is where x can live. And in a rational function, this is restricted because this thing can't be equal to 0. So to find the domain, you come over, bring that over to the right, set it equal to 0. If you factor that, you can take out an x, and that gives you x times x plus 4. Well, this factor, if we set it equal to 0, we get x is 0 and x is negative 4. Those are my restrictions on the domain. And so you would be given a box that says the domain is, and you would have a brace, and it would say all x such that x not equal to, and then you would have a box probably. And so in that box, you would put 0, comma, negative 4. So that's the way you would list that. You're not going to have to remember how to write that, but you would know to put that in the box. All right. Vertical asymptotes, we've done that when we graphed the rational. You take the bottom and set that equal to 0, and you get x is negative 9, x is 3. Those are your vertical asymptotes. We talked about the horizontal asymptote, where you're looking at if the degree of the top and the degree of the bottom are the same, then you take y equals 5 over 7. If you have to find a slant asymptote, and it would tell you that, you're going to actually do the division. You're going to divide this by this. We can use synthetic division, and you should have had that in algebra, where we use the coefficients 1, 9, negative 9, and we're going to divide by 8. Remember that we changed the sign of this, because when you set that equal to 0, x equals 8. So we're going to divide by 8. We bring down the 1, then it's 1 times 8 is 8. You add, you get 17. We get to stop right there. We don't have to worry about the remainder for this asymptote. Remember, if we started with x squared and we divided by x is 8, we drop down a level. So this is y equals 1x plus 17. And that would be your slant asymptote. We need to be able to find compositions of functions. And so if you were given this, you would be given f of x and g of x and asked to find f of g of x. Well, I like to think I'm taking this part and putting it into this part, always right to left. So I'm going to take this blue thing and put it in for x there. So 3 parentheses, this whole blue thing, plus 11. Do your distributing. You end up with 12x plus 8. Okay? You might also be asked to find f of g of 3. You could do that two ways. If you've already found f of g of x, you can just plug in 3 to this. So we would have 12 times 3 plus 8. That would be 36 plus 8, or 44. If you didn't have this, if they just gave you this line and said find f of g of 3, you want to start out to the right. So g of 3 would be 4 times 3 minus 1, plugging it in here, which would be 11. And then you take this and plug it into f, because we're moving right to left. So f of 11 would be 3 times 11 plus 11, which would be 44. So we got the same thing, but we did it a little bit differently. You also might be asked to do something with the algebra of functions, given two functions and find the f minus g, and you literally subtract the functions. You have to be careful. You want to write 9x minus 2 subtract, put this in parentheses. That's going to make you, when you take the parentheses off, remember that's going to change both those signs. So now you have minus 7x and plus 8, and we get this when we combine like terms. You will probably be asked to find the inverse of a function. So if you're given f of x equals this, you want to find f inverse. Well, the rules, there's several steps, and the rules are, first of all, we'll write it as y equals 3x plus 7. Then we'll interchange x and y. Then we'll solve for y. So we're going to subtract 7, and we'll divide by 3. So x minus 7 over 3 equals y. And that's not really y anymore. Now it's inverse. So f inverse equals x minus 7 over 3. Be careful if you have something to a power. Let's do another one. So if you had f of x equals x plus 2 cubed. All right, so we're going to make that y equals x plus 2 cubed. We're going to switch out x and y. Now we've got to solve for y. That's not as easy because we've got this cubed. So to get this out of the cubed, we want to take the cube root of both sides. If it were the fourth root, we'd take the fourth, if it were to the fourth, we'd take the fourth root of both sides. If it were the sixth, we would do the sixth root. So we would have the cube root of x equals y plus 2. Then we would subtract 2. So you would have the cube root of x minus 2 equals y. This would be your inverse. So just be careful. Whatever you have, follow those same steps. Write it as y equals, switch x and y, solve for y. That should give you that. Here. Okay, so if you were asked to use common logs in a calculator and to evaluate this is easily done on the calculator. So we'll pull that up and we'll get out of this. All right, you have an LOG button and the base of it is always 10. So if the base is 10, that's easy. We're just going to put log and 14 and close and enter. And it'll tell you how many places to round. If it were 3 places, that would be 1.146. Alright, so again, just hit the log button and the number. Alright. If you had to expand a log, we have properties about that. Let's see what we need to do on this. So because this is a division as a single log, that becomes a subtraction. So the first thing, we would have log base b of the top minus log base b of the bottom. Alright, then we recognize this is a product and this is a product, and products can be expanded to addition. So we would have log base b of m to the 4th plus log base b of p squared minus log base b of n to the 6th. We also, that's a minus log base b of b to the 7th. We also have a rule that says the powers all come to the front. So we have 4 log base b of m plus 2 log base b of p minus 6 log base b of n minus 7 log base b of b. And the only thing else that you would need to do in this one, log base b of b, anytime you have that, that's equal to 1. That little part there evaluates to 1. And so 1 times 7 is just 7. And so in your final answer, you would just at the end have a minus 7, not this. That would go away. All right, condensing logs, we go the other way. And addition becomes multiplication. So that would be log base b of x, y. Okay. What if we had to do a change of base? That's the log of the argument over the log of the base, because we don't have a log key that has a 4.2 base. So we do log of 69 divided by log of 4.2. And you could just do that on your calculator. You would do log 69 close divided by log 4.2 close and enter, and you get 2.95. Alright, you might be asked to solve a log equation. And if it does not have a base here, it's understood to be 10. So, excuse me, 10, we want to change it to exponential. That's our process. So 10 raised to the first equals the argument. So that'd be 4 minus x. So I have 10 equals 4 minus x. Subtract 4. 6 equals negative x. So negative 6 would equal x. Likewise, if you had a log base 4 of 6 plus x, I don't have any idea what this is going to equal, so we'll see, equals 2. Again, we'll change it to exponential, and so we would have 4 raised to the 2nd power equals 6 plus x. Whoops. So 16 equals 6 plus x. Subtract 6, so 10 would be equal to x. So the base to the exponent equals the argument. All right, now we have several things about matrices. You're going to be asked to solve a system, and you can do this with the calculator. So I'm going to go through this one with you. All right, so we want to go to second matrix and over to edit and hit enter. So this would be, let's go backwards a little bit before we put it in. If we wanted to turn this into a matrix, this would be 1, 1, 1. I'm taking the coefficients in a 6. 1, a 0, a negative 1, a negative 2. No x's, so 0, 1, 3, and 11. So this would be my matrix. That's 3 rows by 4 columns. So if I get my calculator back up, I need a 3 by 4. It should give you a blank matrix. So let me get this over where I can see what I'm putting in. 1, enter, 1, 1, 6. Pop me down to the next one. 1, 0, negative 1, negative 2, 0, 1, 3, 11. You want to check what you've put in, and then you want to do a second quit. You go back into matrix, second matrix, over to the math, and we're going to choose RREF. The quickest way is to go up. So RREF, and then we need to go back in a third time and get the name of the matrix. Second matrix A, and hit enter, and we get this. Let me pull this over here. Let's see where that went. There we go. So that's what I got. My answer is right here. X is 1, Y is 2, and Z is 3. All right. So that's pretty easy. There's a sheet of information about that, the matrix information that you could use to help you with that. All right, multiplying matrices, you're going to go to your calculator and you're going to put them in. Second matrix, we're going to go to edit, enter, and this is a 2 row by 3 column, so 2 by 3, enter, and we would have 1, 9, 4, 5, 2, 2. All right, so second, quit out of that one. Then second matrix, edit, but before I hit enter, I want to go down to B. And so I want to enter, now that's a 3 by 3. And now I got to put these in. So I've got that one in, and I second quit. Now all I want to do is tell the calculator to find the product of A times B. So I go get the name, A, hit my multiplication sign, go back and get B. And I enter, and that would be my answer. Let's see if I can put that there. So that's my answer when you multiply the matrices. Finding the inverse of a matrix, you would do essentially the same thing. You're going to go put it in. Edit, and this is a 3 by 3. So we've got 1, 0, whoops, 0, 8, 1, 2, 3, 2, 5, 3. All right, so second quit. And then all I need to do is go get the name of that. Second matrix A, and hit the inverse button, which is this, and enter. And that is the inverse of that matrix. Okay, let's do one more, condense a log that looks like this. It's a logarithmic expression. It's a natural log instead of an log. So the first thing we want to do is get these numbers in front. Remember, those were powers that could come to the front. So I'm going to rewrite that as ln of x minus 5 to the fourth minus ln of x to the fourth. Remember, a subtraction becomes a division. So we have the ln of x minus 5 to the fourth over x to the fourth. And now we've written it as one log. You want ln in there only one time because that's what it's asking you to do. All right, I think that might give you a good heads up on prep. There may be certainly questions that aren't covered here, but hopefully you'll be able to handle those as well.